So we're going to do these two, the last two probability worksheets together, just to kind of give you an idea of like how to set things up. I know we've gone over a lot of these, but why not? We'll just record it anyway. Skip over it if you remember how to do it. Quarter, dime, and a nickel. All right, we got 3 coins here. We're going to find the probability that the quarter lands on tails. So if the quarter lands on, well, that's just a 50-50 shot, right? So when we say 50-50, those are the odds. 50% you win, 50% you lose, or you could just say 1-to-1. That's basically saying equal odds. All right, but if you have a dime and a nickel and those guys landing on heads, well, then you need to kind of draw a sample space of your conditions, right? So there you can see that the dime is the first event, and then the nickel is the second event, and together they form one event. And it looks like if it lands on heads, it looks like it's going to be 1 1/4 or 1 1/4. And then if you have all 3 coins landing the same way, okay, we're looking at these 2 situations, okay? And if you were to kind of list all of the sample space out, you will notice that there's actually 8. There's 8 different ways that you can have 3 coins going the same way. There's 8 different ways that you can flip 3 coins. So you can see 2 possibilities here, 2 possibilities there, 2 possibilities there. That is a total of 8. So you would just go through the sample space here and just like pick the ones that would be considered a success. And since there's 2, it's 2 out of 8, and that's 1/4. Okay. All right. Now, if they just wanted all 3 tails, well, then that would be 1 out of 8. Okay. So 1 coin will land on heads. Let's see. We've got, I think there were 3 conditions. If you put all of those 8 possibilities here, you'll find that there's 3 possibilities. So a total of 8. 3, you will have 1 head. What is the probability that a random chosen number from 1 to 100 is a multiple of 4? Well, you could draw out the sample space and go 4. Let's see. 4. A multiple would be 4, 8, 12, and so on and so forth. And what you'll find is that there is 25 of those. Okay. And that includes 100. So if there are 100 numbers, it looks like you've got a 1 1/4, which makes sense. A quarter of them are a multiple of 4. There are 15 marbles in the bag. I think we already did this one. When you're looking for the probability that all 3 marbles are green, if you're not going to replace them, that's kind of a big deal. You've got 3 out of a total of 15 to get the first possibility. Then you're going to multiply that by, there's 2 left, and then there's 14 left after you've not replaced it. And then there's 1 left, and there's 13 on the third trial. Okay, so the third trial, there are only 13 balls left. Is that right? Yeah, 15, right. 15, 14, 13. Okay, now if this was with replacement, well then, let me just show you real quick, because that could be a good test question. If it's replacement, then this isn't changing at all. You would be multiplying 3 out of 15, 3 out of 15, 3 out of 15. But without replacement, these are conditions. Okay, things have changed. Okay. All right. Looks like, what is the probability of the letter being a vowel? Well, we've got 1, 2, 3, 4. There's 4 of them, and I do believe there are 11 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it looks like 4 out of 11. No big deal. The probability that a letter before the letter M is drawn without looking, what's the probability of getting a letter less than M in the alphabetical order? Okay, well, let's think. You got A, B, C, D, E, F, G, H, I, J, K, L. Okay, that is before 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like there's 12 possibilities. M is the 13th letter. So out of all of those, You've got 12 out of 26 possibilities, which reduces to 6 out of 13. Okay. A pair of dice are rolled. What is the probability that the sum of the numbers is greater than 6? Okay, the sum of the numbers. Okay, well, let's draw out a sample space. Okay, you've got 1 plus 1. Then what can you have? 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6. Then you got 2 plus 1, 2 plus 2, 2 plus 3, 2 plus 4, 5, 2 plus 6, 3 plus 1, 3 plus 2, 3 plus 3. I'm going to be careful, so I'm going to draw out the whole sample space. Okay, and I know it looks a little tedious, but it's a pattern. It's not going to be, at least you're going to be right. Okay, these are all of our possibilities. Okay, and we're going to circle the ones that are actually greater than 6. Okay, so that's going to be 5 now. 1, we're almost finished. Okay, and these are the 2 die, and we want to add them so that we want to count them if they are greater than 6. Okay, greater than 6. In fact, I can count all of these because it's 6 plus. Okay, now let's figure out how many there are. It should be 36 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1, 2, 3, 4, 5, 7. See, this is what 1, 2, 3, 4, 5. That's 20, 24, 25. That's 29, 30, 31, 32, 33, 34, 35, 36. We got them all. So which ones are greater than 6? We know it's going to be out of 36. So greater than 6. Okay, greater than 6. So that is 1 plus 5 is not. So that is 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 out of 36, which if you divide it all by 3, you're going to get 7 out of 12. You got a 7 out of 12 that it's going to be greater than 6. So that's something I would bet on. All right. A bag contains, where are we at? 7 minutes. A bag contains colored building blocks. There are 32 red, 42 green, 20 yellow, and 18 purple. If you pick one block from a bag at random, find each theoretical probability. So the probability that you will draw purple would be 18 out of a total of 32, 45, 20, and 18. Okay, now, and think of this too. This is not just useful like just in gambling, but it's good for probability is really important for just statistics in general, like whether or not like a drug works. They will do statistical analysis and find these probabilities. Like it's just so useful. So 15 carry the 1, 7, 8, 9, 10, 11. So I've got 115, and I'm actually kind of nervous about that because I just don't believe in myself today. Yep. All right. 115. I should have believed in myself. 18 out of 115. Is that sufficient? Sure. Will 3 go into? Nope. That looks good. Green. Okay. Well, 45 out of 115. Looks like 5 will go into those. What do you got? 9. And then 5, 2, carry the 1, 5, 3. So 9 out of 23. What about not yellow? Well, what we can do is we can go 1 minus 20 out of 115. Okay, that would be fine, right? So that would mean if 1 is 115, that's 95 out of 115. Because this is 115 out of 115. Okay. All right, what about yellow or red? Okay, now I like or. Or's cool. Yellow would be 20 out of 115, but then the red is 32 out of 115. But if you have or, then you're going to do a plus, okay? You add the two together, that's going to be 52 out of 115, and that's it. All right. So, what's the probability that's a consonant? 1, 2, 3, 4, 5, 6. 6 out of how many? Looks like we got 8. So that is 3 out of 4. Okay. What about a vowel or a G? So 1, 1, 2, 3. So 3 out of 8. Not a letter in the word deaf. So that would be 1, 2, 3, 4. 4 out of 8. A, B, or C. 3 out of 8. Because it's 1 out of 8, 2 out of 8, 3 out of 8. A vowel. 1, 2. 1/4. 2 out of 8. A letter in the word giraffe. So how many are there? 1, 2. So how many letters are there? 1, 2, 3, 4, 5, 6. There's 6 different letters. Okay. Now I know that there's 2 F's. So we got to be careful here. Okay. A letter in the word giraffe. We got to be careful here. We're not doing 21, by the way. Letter in the word giraffe. Those 2 F's are kind of messing me up. But we're good. Okay. So 1, 2, 3, 4, 5, 6. 6 different letters. And we've got 1, 2, 3, 4. And that's it. So 4 out of 8. All right. Okay. That's that one. We'll do the next.